Good morning, Landon. I think I can help you figure out how to work with these systems of equations that have three variables. I'm really flying to try and get out of here this morning because this had slipped off my radar, like I told your mom in that email. But let me show you what I'm going to do. And rather than take the example from the book to step through and explain to you what I'm doing, I picked this problem off the sidebar of one of the pages that you sent to me. And then I am going to go back and work through that example in the book. And perhaps by having two examples shown to you, it'll make a little bit more sense. 2x plus y plus z is 9. Negative x minus y plus z is 1. 3x minus y plus 7 is equal to 9. And what you're doing when you have three simultaneous equations that are x, y, and z, I'm sure she explained to you, or that you know, that what you're looking for is the point in space where three lines intersect. And that's where you get the ordered triple. So you have the x-axis, y-axis, and z-axis, and it's someplace out here in space, like right here where I'm pointing, is the intersection of these three lines. And in order to be able to do that, in order to be able to come up with a solution to this, we're going to take two different pairings of these equations so that we can eliminate first one variable. So what I'm going to look here, and I see I just have a z there, that's not a 7. I'm going to go ahead and try and eliminate the y's first. And I'm just going to label these equations as equation 1, equation 2, and equation 3. And I'm just going to go ahead and pair 1 and 2 together first. So equation 1 and equation 2, I have 2x plus y plus z is equal to 9. And then I have negative x minus y plus z is equal to 1. And I'm going to choose to try and think right here. I'm going to choose to eliminate y. I could have chosen to eliminate z. As you know from working with just regular simultaneous equations with two variables, there are always several different ways that you can work with them. If I just add these two equations together, my y variable is going to drop out. So I have 2x minus x is x. Y plus y minus y drops out. Z plus z gives us 2z. And then 9 plus 1, of course, is equal to 10. So we now have one equation in two variables. Y has dropped out of this. What we need to do now, we've already paired these two equations together. We need to come up with a different pairing so that the y variable will drop out again. So I'm going to pick equation 1 and equation 3 because I already have opposite signs on my y. You could have picked equation 2 and 3 to drop out, but I'm going to pick equation 1 and 3. So I now have 2x plus y plus z is equal to 9. And then I'm going to pair that with equation 3. 3x minus y plus z is equal to 9. And again, I'm going to add the equations because I have opposite signs on the variable that I'm trying to eliminate. And whenever I'm doing simultaneous equations, especially if I have to multiply by negative numbers, or sometimes I'm adding and sometimes I'm subtracting, I always put some, like the idiot lights on the cars that say, upshift or whatever, downshift. I put my little reminders out to the side. That's just a mental help to me to make sure that I'm catching things properly. I'm going to add these together. 5x plus 2z is equal to 18. Now we have two separate equations here that we can use to eliminate a second variable. which is exactly what we want to do because we have to get to where we can solve for one variable so we have a number and can begin our process of back substitution. Okay, 2x, 3y, what two equations am I going to be dealing with? I'm going to be dealing with x plus 2z is 10, 5x plus 2z is 18. So what I have here, got the same coefficient in front of the z. I'm going to subtract the two equations. You could multiply by a negative, you could add the opposite, but I'm going to choose to subtract these two equations. So what I'm going to do, let me just rewrite it. I'm going to have 5x plus 2z equals 18, x plus 2z is equal to 10. All right, now I'm going to subtract. Five x minus x is 4x. 2z minus 2z, they drop out, and 18 minus 10 is 8, giving us a value for x of x is equal to 2. So that's good. We've already got the first number now in our ordered triple, which is our solution. What do we do now? This is where you begin the process of back substitution. Just going to take this x and substitute it into either one of your equations in two variables so that you can solve for z. So I'm going to clear some space. Actually, I'm not, and I'm sure by this point you probably got the answer. If I'm substituting x as 2, I'm going to have 2 plus 2z is equal to 10, 2z is equal to 8, z is equal to 4. What I did was I chose to take this equation here, x plus 2z is equal to 10. I took the x is equal to 2, substituted that in for the x, and then solved this simple equation right here to come up with the value of z equal to 4. So we now have two of the values in our ordered triple. We have x is 2, we don't know what y is yet, and we have z is equal to 4. Okay? So now let me go ahead and clear some space on this board. And we can take those two values for x and z and substitute them into whichever of these three equations we choose to. These are all very straightforward equations. And you saw that I just nearly erased that negative, which would be a problem. I'm going to substitute in to this equation here. X is 2, 2 times 2, plus y is what we still need, plus 4 is equal to 9. And you see from that that y has a value of 1. 4 plus y plus 4 is equal to 9. Y has a value y has a value of 1. So we now theoretically have the solution to this system of three equations, and it's the point in space with the coordinates of 2, 1, and 4 where these three lines intersect. And how do we verify that we do in fact have the correct solution? Well, this is when you have to go back and solve and put the ordered triple into all three of your original equations. So we'll do that right quickly. I mean, you can pretty much do it mentally. This problem is so easy. But for the first equation, you have 2 times 2 plus 1 plus 4 Is that equal to 9? Yeah, as soon as you look at that, you see 4 plus 4 plus 1 is 9. So that one works. Our second equation, we have the opposite of 2 minus 1 plus 4. Is that equal to 1? Negative 2, negative 3, plus 4 gives us a positive 1. So this is good. What about our third equation? Can you hear my rooster in the background? He's on my front porch. 3 times 2 minus 1 plus 4. Is that equal to 9? 6 minus 1 is 5, plus 4 is equal to 9. So this ordered triple that we have, 2, 1, 4, satisfies all three of these original equations. So this is the solution to this system of equations. So that's how that works. I hope you're able to slow this video down or pause it or even just track right through it and say, oh, light bulb, I understand what's going on. So what I'm going to do is stop this video now because the shorter videos convert more quickly on YouTube, and I'm going to go ahead now and do one more quick video for you. Actually, it won't be quite so quick because it's more complex, but it's where I'm going to go ahead and take the time and step through that long example they gave you in your book, and hopefully by looking at that book, watching me do it, that will just solidify things for you a little more.